Hi, and welcome to video 3 in my series on the box loader robot. In the last video, I briefly covered moving the box on and off the cart, and I showed the box I found, and I got a little restless and had to order 10 of them. They are already used to store stuff, you will see a little later. Time for turning the cart, and some of my thoughts on the space needed to turn the cart from left to center to right, and the needed reach of the arms to get behind the box on the shelf. But first, some progress on an unrelated sub-project. The actual reason was I had all the elements for the shelves and wanted to assemble them and start using the shelf prematurely, hence all the other stuff not in boxes. Unfortunately, the shelf width is not wide enough for 3 boxes and too wide for 2 boxes, so at some time in the future, a new shelf is needed. Back to the assembly. The bearing ring that makes it possible for the cart add-on to turn. The cart, in a rather rudimentary state, but it works for this show and tell. Finding the center of the cart. Mounting the bearing for turning centered on the cart, aligning with the center crossing lines. The cart must be able to spin 180 degrees to on and off load boxes on both sides. All my 40 centimeter shelves are put to use in the assembled shelf, so for this demo I use two 30 centimeters bolted together. To give you an idea of the 40 centimeter size, the reach the arms need is still quite some distance from the front of the cart, bridging the gap between the cart and reaching all the way behind the box on the shelf. My first experiment just before getting the overextension motorized. I'm still working on how to detect when the arm is all the way back, I guess via a switch. And then I have to detect when the arm is extended all the way. If I can get my reading of the rotary decoder to work, that should be the most reliable way. This is how I pictured the delivery of the box to the shelf will work, pushing the box into the shelf. To demo, I need to supply power for the motor, extra power it is. Happy I could plan my own workspace and add the things needed for future usage, like a plug in the ceiling. When delivering a box, the cart is higher than the shelf, so the box clears the edge of the shelf and slides onto the shelf without hitting the shelf. When retrieving the box, the cart is lower than the shelf, and the box is pulled into the cart without hitting the cart. This demo rig has the arms quite close. This does not leave a lot of room for misalignment with the box and shelves. Alignment and misalignment is an area I will touch on at a later time. In my mind, this is coupled to up and down movement, combined with the left and right movement. So more on that later. Some of my subscribers have asked why I'm not using actuators. And yes, that was in my thoughts for quite some time. But the reach of the arm was an issue I could not solve. I bought an actuator to test the use and it runs on air, but electrical actuators are also available. This actuator is long enough to extend the length of the box. That will get me almost halfway. Unfortunately, I cannot show you this, as the actuator is lying somewhere I cannot remember. The multiple actuators requires at least 2 and probably 3 actuators to reach as far as the arm have to go. I could do something like a crane arm and properly make it with electrical actuators. But the overextending arm with wires to pull it back and forth is my choice at the moment. Thank you for watching. Comments and ideas are welcome.